Hey, 8th graders, today's lesson is day 3 of our phase change engineering internship, and today we're going to be focusing on isolating PCMs and insulating materials. So today we're really going to get into the sim that we're going to be using to build these models and test them, as obviously we can't use real babies to test. So we're going to talk a lot about the different PCMs today and then learn a little bit about the insulating materials that are available to us. So with that being said, your learning targets today, I can isolate independent variables, specifically the PCMs and the insulating materials, to see the direct effect each has on the dependent variable. In this case, we're going to be looking at the baby's average temperature, the time outside of the healthy range, and the cost. Okay, as those are our 3 criteria for this project. Okay, moving on to your bell ringer, you guys have a message today, so go ahead, take a second and read the message. And then moving on to our next activity is a little video to watch called Engineering Tip Using Models. So it talks a lot about the pros and cons of the different models that we can use. So go ahead, right click that link, open up this video, and it'll take you guys into YouTube for this. Take a second, pause this video, and go watch this engineering tip using models video. And when you're done, come on back. All right, so as I said earlier, the whole goal of this lesson is to isolate all those different independent variables that we have, like the different PCMs, the different insulating materials, and see how they affect the 3 factors that we're looking for, the 3 design criteria. So just some vocab for you guys. Isolate is to separate or set apart. Today we will isolate different variables such as PCMs and insulating materials to see which will lead to the most desirable result. We will start with PCMs, which you guys should be fairly familiar with. And then we will look at insulating materials, which are the substances that do not transfer thermal energy very easily. So obviously we're looking at something where we can transfer some thermal energy into a baby, but not have the baby lose a bunch of thermal energy to its environment. So that's going to be the purpose of these insulating materials. Okay, first little part you guys are going to do in the sim is this PCMs. So basically you are just going to test PCM A, B, and C and kind of figure out which one is more favorable. So remember, our 3 goal criterion is to keep the baby as close to 37 degrees Celsius as possible, to minimize the time outside of that range, and to cost the least. So just as we kind of open up, the link is in the title up here. If you guys right click and open that, it'll bring you guys into here. For this first one, we just want to see, all right, what does PCM A do, what does PCM B do, and what does PCM C do? If you kind of look at the left-hand side, you guys can get some general information about all of these. PCM A costs about $15 each. Keep in mind that the actual sleeping bag itself costs about $20. So notice that without any PCMs added at all, we already have a total cost of $20. So then if we were to add 4 PCMAs, which is going to be our first test, you guys can see that that cost is going to reflect the 4 PCMs at $60 plus another $20 for the sleeping bag. Okay, they have a long plateau time, as you guys might remember from yesterday's lesson or day 2. Reheat time, it takes about 55 minutes to reheat, and the plateau temperature is about 36 degrees Celsius. So when we're changing changing phase between the liquid and it's turning into a solid while it's in the little sleeping bag, that temperature is going to be about 36 degrees Celsius. All right, so for each of these, again, we're just going to isolate and see the cause and effect of each of these PCMs. So first one, you guys would use PCM 4 of the PCMA, and then no insulating material. Okay, then in these boxes, you guys are going to record your results for the baby's average temperature, the time outside the healthy range, and then the total cost. And then you guys are going to kind of look at these and you're going to make a list. What are all the good things about this PCMA? What are all the bad things about this? So we kind of already have a little bit idea about the cost. So this one is mid-range compared to PCMB is the cheapest. PCMC is the most expensive. We can go ahead and hit test. And then we can kind of see, all right, here's our data for this. So the baby's average temperature, 35.8. So I record 35.8 in here. Okay, time outside the healthy range. I got 720 minutes, so it wasn't ever really in the healthy range. If you guys look at this green area is the healthy range. At no point does our baby's temperature even go in there. So it spent all 720 minutes outside of the healthy range. That would definitely be a con that we would look for. And then total cost was $80. Okay, then what you guys would do is you would list what are some things that are good about this design. You guys might look at, it has a plateau temperature that's pretty close. It's mid-price, so we might call that a pro, mid-range for price. It has all minutes outside of the healthy range. You guys could just make a list here of all the good things and the bad things that you guys see about this. So any of those would be good as well. They have a long plateau time, which is really nice. So that means it takes time to change phase. So long plateau time is great. However, the time it takes to reheat is also long reheat time. So you guys can think of any other things to add to this. Make sure you guys add them to that list. Okay, and then what you guys will do is you'll go ahead and test PCMB. Do the exact same thing, no insulating material, just 4 of the PCMBs. Record your data here, and then you guys want to make a big list of all the pros and cons, especially comparing it to what we've already seen with PCMA. And then you'll do the same thing for PCMC. Once you have all 3 of those individually tested and isolated, you're going to review your pros and cons for each of those 3 PCM tests. And then if the incubator were to only rely on PCMs, which would you choose for your incubator? So obviously when you guys are building designs, you guys will be able to do a combination, but if you just had to stick to a couple, like 1 PCM, what would you do and why? Okay, and so make sure you guys use some of that data that you collected in these pros and cons tables to help you. So go ahead, take a second, pause this video, finish collecting data for each of your 3 PCMs, and then when you're ready, you can come on back. All right, the next part we are going to isolate the insulating materials, which we haven't looked at yet. So now we will isolate and study the effects of the insulating materials. Insulating materials are a little more complicated than the PCMs because there's 2 different variables you guys can change and test. Type of insulation and the number of layers. So there's 3 different types of insulation that you guys will use. So if I go ahead and hit reset on my little thing here, if you guys look at insulating materials, I'm going to drop this down and look at this one. You guys have cotton, fleece, wool, and then you guys have an option of doing no insulating materials. For each of the 3 cotton, fleece, and wool, you guys can also do 1 layer, 2 layer, or 3 layers. So that's going to be another complicated factor when you guys are designing yours, is you guys can do a variety of these and then see how many different things you guys can use. So I can use cotton, and I think I can use fleece as well. And then layer 2, I can use something different. So I think you guys will have a chance to play around with those a little bit more. Okay, so I already kind of done the first one for you guys, but basically what we're looking at here is just testing the insulating materials, and for this one we're just going to choose none, and then we'll go ahead and hit test. So this would have no PCMs and then no insulating materials. It's basically just the sleeping bag. So if you guys look at the cost, it's $20 there for just the sleeping bag. So make sure you guys factor that in as well, that each of these sleeping bags has cost of $20 plus if you add PCMs or any insulating material. So if we look at this one, 30.2 is my average temperature. So I would record that here. Time outside, 720 minutes. Again, it spent its whole time outside of the healthy range, and then total cost was just the sleeping bag for 21. This one asked for the time for the baby's temperature decrease from 36 to 35 degrees Celsius. So if you guys grab the little green circle down here, you guys can see it starts at 36 degrees Celsius. And then the time is at 0, and then what we're going to do is we're going to drag it until we see this little thermometer here turn to 35. And we're going to stop it right there and say, all right, that was about 50 minutes. Okay, so you guys will be able to get fairly close there. So I recorded, looks like when I did this before, I recorded 51. Okay, so then you guys are going to do the same thing except for this. You guys are going to do your different insulating materials. So you would reset your data. You're going to use no PCMs for this, so we're just looking at the baby's body heat. So we would test cotton with just 1 layer, and then we record it in our data table here. And then we'd go back and we'd add 2 layers of cotton and record our data, then 3 layers of cotton and record our data. So you guys have a little bit more data to look at in this, and you guys will see differences in prices as well. And then you'll also need to go and kind of see, all right, this is just 1 row of cotton. So if I start here, I'm at 36. The second it drops down to 35, looks like it's about 49 minutes So I would record that for my time for the baby's temperature to decrease from 36 to 35 minutes. Okay, you guys are going to do that same thing for fleece, 1, 2, and 3 layers, and the same thing for wool, 1, 2, and 3 layers. And then answer this question here. How do different insulating materials affect the baby's average temperature? So talk about what you notice with each of those different types. And then how does the number of layers affect the baby's average temperature? So take a look at your guys' data for layers. What does that do for your body temperature for the baby? Okay, go ahead, take a second, pause this video, go complete all your data tests for insulating materials up through slide 15. And when you're ready, come on back. Okay, last but not least, you guys are going to wrap up this lesson with another article to read about insulating materials. So you'll right click and open this link up. And you guys will go up, if you're not already there when you open it, to chapter 4, insulating materials. And go ahead and read this short little article about the different insulating materials. Okay, and then finally answer these questions. How will insulating materials help our baby warmer design? So you guys are going to get that directly out of the article. And then just a little project summary. So these questions are coming just from you, not from the article. What is the engineering problem we are trying to solve in this project? Describe the first criteria and keep the baby's average temperature as close to 37 degrees as possible. Why is this important? So talk about why we want to have that criterion. Describe the second criterion, minimize the time outside of the healthy temperature range. Why is that important? And then describe the third criterion, keep costs low. Why is that so important? So think about what you've learned so far about this project and what we're supposed to be doing on it. And then finally, based on your research so far, which criterion do you think is going to be the most important to create a successful incubator design? So circle your answer here and then tell me why you chose that answer. Okay, finally, once you're all done, do your wrap up. Do you have any questions, yes or no? If you do have any questions, type them right here. Otherwise, leave that blank. And then 4, 3, 2, 1, how do you think you did on the assignment? You were all done. Go ahead and hand it in, and we will talk soon.